Previously, we've created the basis for UI framework and we've updated our sample tests accordingly. So, our current solution is operational for trivial cases. But this time, we'll take a look at more complicated cases which appear as soon as you start working with more or less complicated environment. In this section, we'll go through several quite common cases for complex pages and elements handling. Firstly, we'll take a look at platform-specific identifiers and how to deal with multiple independent platforms. Secondly, we'll work on customizing elements behavior to make custom elements compatible with standard elements. Then, we'll take a look at how to deal with compound elements containing sub-items. And, in the end, we'll go through some additional functionality which helps us with the verifications and which would be helpful in the future. In first video, we'll take a look at platform-specific identifiers. They normally appear when we operate with same application implemented under different platforms. In this video, we'll introduce the enhancement which handles platform information. We'll create functionality supporting multiple object locators for the same element and apply changes to choose the most appropriate locator for the platform. In the end, we'll create an example which verifies objects on page using platform-specific locators. We'll exercise the same test on web and Android platform to demonstrate that we can declare page objects for several independent and incompatible platforms. So, let's get started. Since we introduced the concept of platform, we need some entity which stores relevant information about it. The first step is to create new type called target platform. Here we use enum, while after all we need to have some string representation. Thus, we have to associate an enumeration value with a string. We'll do it by assigning description attributes where description value reflects the browser string we use in our configuration. In addition to browsers, we'll add two more entries for Android and iOS native applications. Also, we'll add an entry called any. It will be needed for filtering when we need some identifier matching all supported platforms. Now, we need the way to get strings associated with the enum value. We can do it via extensions. Here, in the same file, we create a static class named targetPlatform-methods and add the first static method name. Notice the way the parameter is declared. It contains this statement before the parameter type. Such notation indicates that this method would be an extension of the parameter type, which is the target platform in our case. In other words, after such declaration, the target platform will have a new method called name, which will actually invoke the method we've just created. Now, let's implement it. We take the description attribute of the enum value we pass as the parameter. After that, we get the description field, which is then returned. This is quite complex way to get the string value associated with our enum fields. Then we can add two more extension methods detecting whether our target platform is mobile or web platform. Let's add isMobile method first. The target platform enum is considered as mobile if it is defined as any or any mobile specific value. In our case, it includes two constants for Android and iOS respectively. Then we can add isWeb method, which returns true when selected enum value is any or none of mobile values. And finally, we need to have an ability to convert browser string into enum value. For this purpose, we'll add new value static method. This time it's not an extension. It will go through all target platform enum names and get the description attribute value. If current description equals to parameter we pass, we return the enum with a specific value. If we pass some unknown string, the result would be any. Now we are done with the enumeration. Next step is to update configuration object to handle the platform. Here, we'll add the platform property which returns proper target platform enum value based on configuration. Additionally, we'll add new configuration option which points to the driver path. For web browsers, it would be the path to driver utilities we use to interact with browsers. For mobile drivers, we'll use the same option to point to external driver URL. We'll get back to that later. And finally, we need to update the driver object. It uses hard-coded values for browsers. Having target platform enumeration, we can replace hard-coded strings with the values from enumeration. Since we are going to introduce native mobile application support, we also need to add Appium client reference. Once we have it, we can update driver object with 2 additional entries in driver map field. Those entries correspond to Android and iOS drivers respectively. Now it's time to add platform handling into locators and into find-by attribute in particular. Firstly, since we potentially need multiple locators, we need to make our find-by attribute repeatable. For this purpose, we just need to add allow multiple field to the attribute usage attribute and set it to true. After that, we can add platform field which returns any by default. This way, we keep compatibility with the previous behavior. Now, we have to handle find-by attribute from pages. For this purpose, we need to update page factory class. What does it change this time? Firstly, instead of getting single attribute, we can use getCustomAttributes method. It will return the array of attributes of find-by type. Now, we need to get specific find-by attribute matching the current platform from the list of all find-bys. For this purpose, we'll add new static method. Let's name it getLocatorForPlatform. It goes through an array of find-by elements and returns the item which platform matches the parameter we pass. If nothing matches, the null value is returned. Now, we can get back to init method. We have an array of find-by elements and we have method filtering this array by the platform. Let's initialize new attribute object with the find-by element which contains current platform. If this object is null, we'll try again by searching for platform with the value of any. Additionally, we may add search for any web locator as in most of the cases web locators are browser independent. All that manipulation means that if we don't find specific locator, we'll look for common locator then. Once it's done, we just initialize control object with the locator string. So, after all those changes, our page factory now handles multiple find-by attributes, and it can choose platform-specific one. Now it's time to update our sample test pages with platform-specific locators. Right now, we'll take the search page. I chose Booking.com application for the purpose. It's available both as website and native mobile application. Initial UI is almost similar, but what is definitely different is identifiers. Let's open Appium and see how corresponding UI objects are defined. For the Appium setup information, please refer to Getting Started page of the official Appium site, which URL is on the screen. Here, I'm using Appium Inspector running Booking.com Android application for the Genymotion simulator. If we take a look at each identifier we are interested in, we can see that each of those elements contains resource ID, which is used as ID for Appium. This is pretty much good, as ID is one of the most convenient locators. Now, for search page class, we'll add additional find-by attributes for each field we need and we'll set corresponding identifier from the mobile application. After all the changes, we have updated search page, which is now supposed to be compatible with both web and Android versions. Now it's time to prepare sample test. At the moment, we just need to prove that we handle UI definitions depending on the platform, so we don't need to dig too much into behavior of the applications. Handling different behavior of similar elements on different platforms will be covered in the next chapter. For this video, we'll create new test which verifies UI elements on Booking.com landing page. We can open existing test class and add new test method. We initially assume that we are on landing page and the search page instance is initialized as it's done in the setup method. For this sample test, we just make sure the landing page elements are visible. We can run it to confirm it works for web application. Now, let's make changes to make it running for Android. Firstly, we'll update driver initialization. For mobile applications, we need to specify two major capabilities. They are application path. I'm using application package, which can be downloaded from the device. It's a APK file. Generally, it's needed if application isn't installed on the device. Second, platform version, the version of Android platform to run tests on. Then, we change first parameter of the driver add method to use the target platform enum instead of string. After that, we go to the driver class and change the parameter type for the add method. Unlike browser-targeted WebDriver instances, the Appium instances require URL to connect to. Thus, we need to have if-else condition for web and mobile drivers. If we use mobile application, we should use a bit different constructor which accepts the URL. After that, we can go to the test class and check setup method. We are almost there. One last small tweak. We use navigate method to open the page, but for Android application it appears at the application start. So, we have to update this method to open the page only for web applications. Once we have it all, we can change our configuration to point to remote driver URL instead of driver path and define target platform as Android. Now we can run our sample test for Android. It passes. Now let's switch back to Chrome configuration and we'll see that the same test for web application also works. This is it for this video. We've introduced multiple locators for page elements. Also, those locators are handling different platforms, selecting the one which corresponds to currently configured platform. And finally, we've created sample test which is runnable both for web and Android. Since those two applications use different UI type with different identifiers, the successful test run results prove that platform-specific locators enhancement works. In this video, we've just looked at the way to define similar elements and different locators for different platforms. But our elements may also behave differently on different platforms. It makes behavioral difference.